This is the retake tutorial for Unit 1A assessment. In the first question, you are to sketch the following graphs. You're given information about M and B, which comes from y equals mx plus b, our slope-intercept form. So the first one says M is 0 and B is negative. So M is our slope. 0 slope means horizontal. B is our y-intercept. Negative would be below the x-axis. So we would have to have a function that looks like that. And the second one, it talks about M is negative, which means our slope is decreasing, and B is a positive. So as long as we intersect the y-axis anywhere above the x-axis, we could have something that looks like that. And the third one, M is positive, so an increasing slope with B equaling 0. 0 is the origin, and so we would have a line that would go straight through the origin. That could look something like that. Questions 2 and 3 says find the inverse of y equals 2x minus 5, and we need to do it both graphically and algebraically. So number 2 is the graphically. So if we were to graph this, we could use our M and B like we saw above. M is 2 and B is negative 5. So we graph the negative 5 first, and we use our M, our slope, and do rise over run, up 2 over 1, up 2 over 1, so on and so forth, or down 2 and left 1, down 2 and left 1. All right, we draw our straight line. If we're going to draw the inverse, we're going to want some points. Ordered pairs will make it easier. So let's pull off some points from our original function, which we know the y-intercept was located at 0, negative 5. We could pick the very next one off of that, which was when x is 1 and y was negative 3. And then when x was 2, y was negative 1. All right, we could go the other direction. X was negative 1, y was negative 7, and x is negative 2, and y would be negative 9. Now to get our inverse function, we learned that you would switch the ordered pairs. So negative 2, negative 9 is negative 9, negative 2, and then we could graph that. Negative 9, negative 2 would be right there. And then negative 7, negative 1 is right there. Negative 5, 0. There's an x-intercept. Our y-intercept became an x-intercept. Negative 3, positive 1. And negative 1, positive 2. And we can draw our straight line there. Okay. Remember that if we wanted to check if these actually were inverse functions, we could draw that diagonal line through the origin, right? Y equals x, our linear parent, and we can see the reflection, and we know that that is a true inverse. All right, and then question number 3 now says algebraically. Remember, there's 2 steps algebraically. Step 1, switch x and y. We're talking about the variables. Switch 2, we then solve for y. Okay, so let's do that. So we have y equals 2x minus 5, and now we switch. So this is x, and this is y. Right? These switched. All right, and now we would solve for our y. So you undo subtraction with addition. We now have x plus 5 equals 2y. We divide everything by 2. And we use our notation. F to the negative 1 of x is x plus 5 over 2. Or if you want to divide it out, our slope is 1 divided by 2, which is 1/2 x. And our y-intercept is 5 divided by 2, or 5/2. Number 4. Okay, this looks like regression, right? It says Sandy recorded the number of cars in a school parking lot after 6 a.m. She gets some data. So we have minutes, right? 0, 30, 45, 55, 75. Number of cars, 3, 8, 20, 64, 98. So we're going to want to use those regression steps. Remember, that is, we go to our stat, we hit edit, we're going to put those minutes in list 1. You're going to put number of cars in list 2. Right, list 1, list 2. You're going to go back to stat, hit calculate, and go down to number 4, which stands for linear regression. Okay, you're going to get your equation. All right, if we go to our calculate, you can make sure you scroll all the way down until you actually get an equation. It says y equals ax plus b. It tells you what the a is. If you got the correct a, right, you get 1.2924, right, and it keeps going, blah, blah, blah. And then our b, which is going to be our y-intercept, is negative 14.3895, and it keeps going from there. And I said we needed 3 decimal places. So 3 decimal places is 1, 2, 3. We look to the one to the right to see if we round up or down. That rounds up. 1, 2, 3, and the 4 rounds down, which means it doesn't change. So we can write our equation. So we get y equals 1.292x minus 14. Now this 389, the 5 is going to round that up. And you really need to think of those last two as together. So 89 becomes 90 because we still need the 3. So 390, 390 thousandths. All right, then the question says about how many cars would be in the parking lot at 90 minutes. We know minutes is our x value, so we just plug that 90 in for x, and we solve for y. Right, so 1.292, in parentheses we put our 90, minus 14.390. All right, if you plug that in there, you got 101.89. We know we're talking about cars, so we need a whole car, right? So we'd say about 102 cars. All right, the last question on this page says, write the equation of the line with a slope of 5 that passes through the point 4, negative 8. And it wants it in point slope form. They give you the formula right there. So our point is x1, y1, and slope is m. So we just plug them in. We get y minus the y value of the point, which is negative 8. We'll fix that in a minute. Equals 5 in parentheses x minus 4. We don't typically leave minus here, so then what we would see would be a plus. And let's look at our next page, number 6. So we have f of x is 5x minus 8, and g of x is 3x plus 6, and it says find the following. When we see two functions side by side, we need to remember that this is composition. Remember, composition meant a mixture of functions. And number 6, we see a number on the inside. And if you remember, I said numbers in gets a number out, whereas number 7, we see a function inside. So function in, function out. Let's start with 6. So we would want to evaluate what g of negative 4 is first. And so we substitute the negative 4 wherever we see an x and simplify that. That's negative 12 plus 6, which is negative 6. That's the output of the inside part. Now we need to go to the next one. So now we need to do this function, because now we have f of negative 6. And so we take our function f, the rule says 5 times our input, which was negative 6, minus 8, which is negative 30, minus 8. So in the very end, our final complete function, f of g of negative 4, equaled negative 38. All right, 7. And this time we have f of g of x, and x is already in g, meaning we already know what g of x is. It's up here, right? 3x minus 6. So we only have to do this once. We're going to put function f on the outside. G of x is going to go on the inside, and g of x is 3x plus 6. Remember, function f's rule was 5 times that input minus 8. And so let's put our 3x plus 6. We then distribute. Make sure you distribute both. 15x plus 30 minus 8. And our final f of g of x is 15x plus 22. Alright, so 8 and 9 are for this graph here that we see to the right, and this is our domain and range, and this is our different notations. So we need to pay attention. Inequality notation, right, with our inequality signs, and then number 9 is going to be interval notation. That's the one with parentheses or brackets. Alright, so number 8, domain and range. Well, domain, right, is our x-axis. It's when we're reading left to right. And when I start on my function going left to right, I run into these arrows, which means infinity, right? From the left is negative infinity, to the right is positive infinity. So our domain is negative infinity. You cannot include infinity if you don't see a closed point there, not an arrow, and we don't include it. So there's our domain. Now range is from the least to the greatest. So the arrows are for the range the least. All right, they're pointing both down. However, as we go to our maximum value, we see that it is at the 8. So on our y-axis here, it'd look like this. 8, negative infinity. But we go least to greatest. So we're going to go negative infinity is less than y, which is less than or equal to that 8. All right, and then the one below it, now we're going to do the same thing, but in interval notation. So we still have negative infinity to positive infinity, and remember not included is parentheses, and for the range, negative infinity, comma 8, parenthesis, but this time the 8 is a bracket, saying that it was a closed point. And number 10. This time we're doing composition again, but this is for a purpose. We're using composition to prove that two functions have an inverse relationship. And in order to do that, we know that we have to use composition in both directions, meaning we need to put g of x into f, and if that works, we need to go the other direction. We need to put f of x into g. All right, so let's start with the first one. So if we take our g of x, which is 1/2 x plus 4, and we put that into function f, that rule is 2 times that input minus 8. So rewrite your 1/2 x plus 4. You distribute. 2 times 1/2 is 1. 2 times positive 4 is positive 8. And don't forget the minus 8. And so down here, f of g of x is x. So it worked. So that means we have to actually do the other one. And so we take our function g. Our input now is going to be 2x minus 8. We have to go the other direction. G's rule was 1/2 that input plus 4. So let's write function f inside here, 2x minus 8, and then distribute. 1/2 of 2 is still 1, so 1x. 1/2 of negative 8 is negative 4, and then we had the positive 4. And so our final g of f of x was also x, right? Negative 4 and positive 4 undo each other. And so when we get out what we put in, meaning this x right here matches this one, and this x right here matches this one, we say yes, that's an inverse. And that's it.